Alright, so graphing a cube root function. Okay, we always want to figure out that HK point, right? Okay, that's our shift left and right. What is that HK? Remember, opposite what you see with X and then what you see for the K value, right? Caitlin? 3, 2. Okay, so we can go ahead, we can plot that point. That's what we call that inflection point on a cube root function. Okay, now, what are some X values I want to use on the table here? Alex?
-8, -1, 1, 8.
Why do we use those values? Doing cube root, right? All those values are perfect cubes, right? Because when we've done all graphing all year, the middle column is what's changed, right? Depending on what type of function we're doing. Now we're doing a cube root function. Okay? Cube root, not perfect cube is the cube root, right? Cube root of -8 is -2. Cube root of -1 is -1. Cube root of 1 is 1. Cube root of 8 is 2. Okay, and then in that third column, 8 times that middle column, right? Mason, what's that A value?
4, 2, -2.
A value is -2, and then when we multiply, we get what again, did you say?
4, 2, -3,
Good. Then we ignore the middle column, right? Now, -8, 4. What is that telling me? Aubrey?
Left 8 up 4.
Left 8 up 4 from?
The point.
From that point, right? Okay, that inflection point. So left 8, what do we say, up 4? Okay, so then the -1, 2 says left 1 up 2, right 1 down 2, right 8, down 4. So split there. Okay, now we got a graph, right? I want to see those 5 points when you do this, please. I need to see 5 points. Okay. And with these cube root, we'll have both branches, right? Square root, that's where you just have the one branch. You got a restricted domain with those square root functions, correct? Now, what is the domain and range of all cube root functions? Alex?
X to the element of all real.
X to the element of all reals. And the range?
Y to the element of all real.
Y to the element of all reals. And we can see that with the graph, right? That's going to go left and right forever. Okay, so that's our domain. We get everything. Same thing with the range. It's going to go up and down forever, right? All right, questions on graphing? Okay, and we did that. Was it Thursday? We did that on Tuesday. Okay, so we're going to solve equations involving radicals now. Now, just like adding is the inverse operation of subtracting, right? And vice versa. Multiplying and dividing are inverse function or inverse operations of each other. What's the inverse operation of radicals? Like squaring, inverse of square rooting, right? Cubing, inverse operation of cube rooting. Okay, so that's the idea that we have to have. So, just like we did in the first lesson of this chapter, you'd always isolate the variable, right? Same thing, we just got 4th root of x. We need to isolate that. So we got to get rid of that 5, right? How do I get rid of the 5? Hayden? Subtract 5. Subtract 5. Now, what do I have on that left side? Is it just 4th root of x? Jessica? Yeah, good. Negative 4th root of x equals that -5. Maria, how do I take care of that negative? It's like saying -1 times that, right? So divide by -1, or if you want to just flip every single sign, right? And that's going to make it equivalent. So 4/3 of x is equal to 5. So how am I going to undo a 4th root? Solving, got an idea? Take it to the 4th power, good. We take both to the 4th power, right? And then, at that point, we rewrote that real quick. Okay, 4/3 of x, and we take that to the 4th power. That's x to the 4/4, isn't it? Which is just x. So that's how that's working. So we got x equals 5 to the 4th. Not gonna have a calculator. 5 times 5 is 25. 25 times 5 is 125. 125 times 5. 625. Okay? So if you need to, test time, quiz time, whatever, just go off to the side and do that multiplication, right? Now, one thing else we need to do with this is to check our solutions. Okay? So I'm dealing with radicals. In this case, it's an even index radical, right? So we need to make sure whatever we get for our answer doesn't cause the radicand, or whatever's inside the radical, to be negative, right? If I was to plug 625 in there, we can take the 4/3 of 625, can't we? Which is 5, so 5 minus 5 equals 0. Should be good, right? So come test time, make sure to check. Okay, it's not everything you do, it's not a bad idea to check, right? A lot of times people are handing tests, quizzes in way before the time is up. Use that time, check your answers. Make sure you're not making those little mistakes, right? It's just good test taking strategy. Alright, so for the next one, we got a rational exponent, right? Again, rational exponents, those are just radicals, aren't they? If you rewrote them, just another way of writing them. So I got to get this x to the 4/3 by itself. How would I do that? Matt? Divide both sides by 3. And I'm just left with x to the 4/3 is equal to something. Can't do that in your head, then you're just going to have to go off to the side, right? 243 divided by 3. 3 doesn't go into 2. 3 goes into 24. 8 times, right? Okay, 3 times 8 is 24. Subtract at that point, 0. Bring down that 3. 3 goes into 3 one time. 81. Now, there's a couple of routes you can go with this now. Keep it in exponential form, or you can switch it to radical form. Okay, let's stick with the exponent form right now. Now, I got to somehow get that 4/3 to be 1, right? How do you what do you got to multiply a fraction by in order to make it 1? And multiply by the reciprocal, right? And then if I need to multiply them, I'm going to have to take it to a power, right? It's power to a power, we multiply our exponents, right? So I'm going to take both sides to what power? 3/4. Which will give me just x on this side. Now, this is one where it's probably going to be easier to write it in radical form on that side, right? What is 81 to the 3/4 power saying? Morgan? 4 fourth root of 81. And I always like to do the parentheses, right? Because if we can simplify fourth root of 81 to a whole number, then we're going to take that whole number and cube it. What is the fourth root of 81? Break. This one we can break down in our heads, right? 9, 9, 3, 3, 3, 3. We're looking for a group of 4, right? So fourth root of 81 is 3, and then cubing that. And 7. Now, one thing with this way, like when we were to solve x squared equals 4, you square root both sides, right? And when you're in the process of solving, and you take an even index radical of both sides, what else do we have to consider? Plus or minus, don't we? What type of radical did I take on both sides here? So what else do I need? Took the fourth root of both sides really, right? And just cubed it at the end. We need to have plus or minus. Now, you still need to check our answers though. Okay. But because we took the fourth root of both sides, we have to have plus or minus. And when I check, okay, so let's check our answer here. We got 3x to the 4 thirds, so it's saying 3 times 27 to the 4 thirds equals that 243. 3 times negative 27 to the 4 thirds equals 243. And this one I wouldn't recommend just doing in your head. 27 to the 4 thirds, that's saying cube root and then take it to the fourth, right? So over here that's saying 3 times 3 to the fourth equals 243. Everyone agree with me there? I took the cube root of 27. 3 to the fourth, that's 3 times 3 is 9. 9 times 3, 27. Times 3 again, 81. Which is 243. Okay, so the positive answer worked, right? Now when I check this one, what's the cube root of negative 27? Megan? Negative 3, right? We're going to take that to the fourth power. Now since I'm taking it to the fourth power, that's going to change it back to that positive, right? So that gets us back to that 3 times 81, which equals 243, which is a true statement. Okay, so if you keep it in this rational exponent form, which you have to remember, okay, if you're going to have to take it to a power, right? So we multiply our exponents. If that denominator of whatever power you're taking it to is even, you got to remember, you're taking an even index radical. And whenever we do that in the process of solving, plus or minus, right? So let's go ahead. Let's change it to radical form. So again, if you're stuck in one form, you can always change it to the other, right? Okay, see if you can solve from there. So it'd be 3 cube root of x to the fourth, correct? Equals at 243. Okay. So in order to get rid of 3, we're going to divide by that 3. That's that same step, right? Then you got cube root of x to the 4th equals that 81. Now it's a cube root, right? How do you undo a cube root? Cube it, right? Then you're going to get x to the 4th equals a very large number. So you can go that road. It's going to be harder though, right? And let's not even go that route. So if it's an exponent, if it's in exponential form, try to keep it that way. Okay? Because I don't want to do 81 cubed. And then take because then eventually we're going to have to take the 4th root of that also. That's going to be dealing with very large numbers, right? Let's avoid that, especially with no calculators. I have told you that, right? No calculators for this test? Yeah. Again, make sure you're checking your answers. Okay? So, this one now. You want to isolate the radical, right? Then we get the square root of the quantity 2x plus 8 minus 4. So I got to get rid of that minus 4, right? Cody, how do I get rid of that minus 4? Add 4 to both sides. So I'm going to have the square root of 2x plus 8 equals 10. Drew, how do I undo a square root?
I don't know.
Aiden, can you help him out? I'm saying it within square root, the opposite of square rooting is square. Okay, so I got to square both sides. Okay, because then that's going to get rid of the square root. And I'm just left with that 2x plus 8 equals 10 squared, which is 100. Do I have to worry about plus or minus here? This is a common mistake I see. Is it plus or minus 100? We squared both sides, right? If you are to square root both sides, then we have to have a plus or minus, not when we square a cube. 10 squared is just 100. So don't mix up when you have to have the plus or minus. Only when you take an even index radical of both sides, that's when you have to worry about the plus or minus. All right, so we got 2x plus 8 equals 100. Subtracting that 8 then, we get 2x equals 92. Divide by that 2, we get x is equal to 46. Okay, now let's check our answer now. Okay, so we got the square root of 2 times 46 plus that 8 minus the 4 equals 6, which is the square root of 92 plus 8 minus 4 equals 6. Square root of 100 minus 4 equals 6. 10 minus 4 equals 6, which 6 equals 6. Always check. Always check. All right, now we got 2 radicals in there, and we're subtracting, correct? Whenever you add or subtract, the radicals have to be exactly the same, don't they, in order to add or subtract? Is that the case here? Square root 4x plus 28, square root 2x. Those are different, right? So I can't combine that left side. So the way we take care of that is we get one radical equal to the other radical. Okay? So in order to do that, we're going to add 3 square root 2x to both sides. So I'll have square root 4x plus that 28 equals that 3 square root 2x. Now I can take care of those square roots. How do we undo a square root? Stainer? Square it. We square the whole side, right? The whole left side, the whole right side. Okay? It's nice on the left side because that's just going to cancel out the square root to give us that 4x plus 28. Other side a little bit different. Okay, so that's going to say 3 square root 2x times 3 square root 2x. So you got to be able to multiply. Three times 3, we get 9. Square root 2x times square root 2x. Anytime you multiply 2 square roots of the same thing, it's just going to be that radicand, right? So we got 4x plus 28 equals 18x. Get our x's together, right? So we're going to subtract 4x from both sides. We get 28 is equal to 14x. Divide by that 14. We get x equals 2. Okay, so just this one we can probably just do a quick mental check. So 2, if I plug in 2, that's going to cause that to be 8, right? 8 plus 28, 36. Square root of 36 is 6, so we get 6 minus 3 times the square root of 4, which is 2, right? 2 times 3 is 6. 6 minus 6 equals 0. Okay. It worked, right? So we're good. Now, a common mistake people make, they like to just square both of those. Can I do that? No, you cannot do that. Okay? Whenever you do something to an equation, it has to be to that whole side. Okay? And even if I did that, that's saying square root of 4x plus 28 minus 3 square root of 2x times square root of 4x plus 28 minus 3 square root of 2x. Is that going to get rid of the radicals if I FOILed that out? That's not something I want to FOIL out anyway. Okay, so you need to remember, if you see 2 radicals, get them on each side of the equation, then square it. Or cube it, depending on what type of function it is. But it's not a matter of just squaring both. When you square something on an equation, it has to be squaring the whole left side, squaring the whole right side. So you need to isolate those radicals before you do that. Go ahead, give that one a try. sure to check your answers in the end.
Square that whole left side, right? X plus 2 squared. Equals one squared. Apply that on there.
Okay, hopefully we've gotten to this point. You're gonna square both sides, right? Is that x squared plus 4? Guess a lot of us did that. Okay. Remember, this is saying x plus 2 times x plus 2. Gotta FOIL that out.
What's that? I'm gonna be teaching you, so if you want to go to the hallway. Yeah, I got some personal whiteboards there, you can grab one of those and use that.
Okay. So, whenever we get a radical equation, radical in the equation, right? Isolate the radical, it's already done, right? So, we have to undo that square in some way. How do you undo a square root? Mara? Square it. Okay, so remember, we're squaring both sides, the whole thing, the whole left side, the whole right side. Okay, that takes care of the square root. And then again, x plus 2 squared, that's saying x plus 2 times x plus 2. And then we can get rid of the radical on that side. Okay. And we FOIL that out, and when we FOIL that out, you should get x squared plus 4x plus 4, correct? X squared plus 2x plus 2x, so 4x. Now this is like quarter 2, right? Solving a quadratic. Whenever you solve a quadratic, get it set equal to 0. I'm going to subtract that 2x over, subtract that 28, and we get x squared plus 2x minus 24 is equal to that 0. And then we got all our methods of solving quadratics, right? If factoring works, go that route. It's going to be a lot quicker. X, x, signs have to be opposite. What am I going to use for those last two terms? Morgan? 6 and 4. Which one's positive? 6. Okay, 7 equal to 0. X equals -6. X equals 4. Okay, now check. Okay, basically when it comes down to these checks, you're making sure you don't get a negative value inside the radical. Okay? So, when I check this one, -6 plus 2 equals the square root of -12 plus 28. So -4 equals the square root of 16. -4 equals 4. Did that one work? Does -6 work? No, it does not. So anytime you get to this point right here, you get a negative value set equal to the square root, then you can stop there and say, nope, that one does not work. Now, when you're doing your check, don't make the mistake of saying square root of 16 is plus or minus 4, because remember, you only do the plus or minus when you're in the process of solving. When you're checking an answer, you are just evaluating. Alright? So the -6 didn't work. So let's check the 4. 4 plus 2 equals the square root of 8 plus 28. Saying 6 is equal to the square root of 36. 6 equals 6. Forward. So that example right there should tell you need to check, right? You can't just assume that they're both good. You need to check. Okay, go ahead, give that one a try. Okay, isolator radical, right? What's my first step to isolate that radical? Ethan? Minus 10. And I got square root of 6x minus 5 is equal to that negative 7. Expander, next step. Square both sides. When I square that radical, it just gives me whatever's inside. Equals 49. Maria, next step.
Let's have 5.
Add 5 both sides. So 6x is equal to 54, correct? Matt, next step. Divide both sides by 6. X is equal to, Morgan? 9. Good? Call her a day? Mara, what should we make sure to do? Check it. Okay, square root of 6x, so 6 times 9, that'd be 54. Minus that 5 plus 10 equals 3. Okay, so square root of 49 plus 10 equals 3. 7 plus 10 equals 3. Something wrong there? Does that answer actually work? No. Hey, that's the only thing I found. And it didn't actually work. What does that mean? Caitlin? No solution. Okay, just think. I'm going to get, if we can't have a negative inside this radical, right? It's got to be positive. I mean, I'm going to have a positive value plus 10. If I take a number, a positive number plus 10, we'll never get 3. Oh, so that one doesn't work. You can solve, you get something. When you check, it does not work. So again, is it important to check your answers? Yes, it is. Okay, so your assignment, 7.6 book assignment. Handful of equations solved there. Book assignment, so again, check your answers. Make sure to go to the content library textbook. That'll be under 7.6 practice, and it'll have the solutions to those questions, right? All right, we got 6 minutes. Probably get a few done. Let's use our time wisely here. Sure, we want to go ahead and stop that.